A carbon fiber manufacturer is affirming its commitment to the upstate, expanding operations with a new investment worth $600 million.
Carbon fiber has revolutionized industries like aerospace, aviation, automobile, construction, and even consumer electronics.
Researchers at Sandia National Lab say carbon fiber may help make wind turbines work better.
From the phone cases that we use to the cars that we drive and to the planes that fly above us, carbon fiber is used everywhere.
Carbon fiber. Now it makes up about 70% of a Formula One car's weight.
Global market size is expected to grow from 3.59 billion in 2024 to almost 7.05 billion by 2032. India's imports of carbon fiber have been rising steadily, with a 41% year-on-year rise in February 24 as compared to February 23.
Reliance is building India's first world-class integrated carbon fiber plant at Hazira, which will rank among the top 3 units globally.
But what makes this material revolutionary? Why is this material increasingly adopted across industries? What are the challenges that come with using this material, and what does the future hold for carbon fiber? Let us delve deeper into these questions in this video. Before carbon fiber was invented, materials like steel, aluminum and titanium were used in satellites and spacecraft. These materials, although stronger, were heavier in weight. This increased the weight of spacecraft. When the weight of spacecraft increases, it needs more fuel to escape Earth's gravity. When spacecraft and satellites started to carry more fuel, this again increased the weight, thereby creating a cycle which ultimately led to the increase in cost of launching spacecrafts and satellites. Moreover, when the weight of the spacecraft increases, it makes the pilot's job difficult to maneuver and control the aircraft. This is where carbon fiber comes into play. Carbon fiber's strength to weight ratio is 18 times as compared to titanium strength to weight ratio, which is the highest of all three. So for every kilogram of carbon fiber used, it can handle more stress and load without difficulty. This is why companies like NASA are using carbon fiber in their spacecraft, and brands like Ferrari and McLaren are using carbon fiber in their Formula One cars. In fact, SF24 launched by Ferrari in 2024 is made of 61% carbon fiber. Corrosion is a silent enemy in construction and automobile industry. It weakens critical infrastructure such as bridges, buildings and roads, and it affects a vehicle's performance, aesthetics and safety. Corrosion is a natural process whereby materials like metal react with air, water and chemicals, degrading their quality. For example, materials like steel react with oxygen and water, forming iron oxide on the surface. This iron oxide or rust formed on the coating not only damages the aesthetics of steel, but it also affects load-bearing capacity of structure. Carbon fiber, rather being made of metals, it is made of carbon atoms which are arranged in crystalline structures. This is what makes them rust resistant. Hence, in building maintenance and retrofitting industries, CFRP or carbon fiber reinforced polymers are extensively used. CFRP is a composite material made of carbon fiber and polymers such as epoxy resin. These polymers hold carbon fiber together, making them very stronger. Carbon fiber wraps or strips are applied to the surface of steel and concrete structures. They prevent the reaction of environment to the structures underneath, making critical structures such as beam, columns and foundation rust resistant. In design, flexibility is very important. Most of the products that are created are never used as it is. Rather, they undergo several modifications in order to fit with client's need and designer's vision. While aluminum, steel and titanium have higher strength, their flexibility is often poor. Excessively bending any of them can damage or deform the material. On the other hand, carbon fiber has higher strength to weight ratio and exceptional flexibility. The best example to demonstrate this is the design of aircraft wings. While steel is more rigid and aluminum is less stronger, carbon fiber is the best material to design this. Engineers can create wings which are structurally strong in order to resist all the stresses and yet fit the designer's vision. This is why wings of the designer 787 from Boeing were designed using carbon fiber. In fact, the company has claimed that using composite materials have increased their fuel efficiency by 25%. So these features such as high strength to weight ratio, good corrosion resistance and increased flexibility, along with other advantages such as high stiffness, good fire resistance and increased conductivity, makes the material extraordinary. But if carbon fiber is exceptional, then why are all companies not using it? There are three disadvantages of using carbon fiber. The first one is the increased cost. Manufacturing carbon fiber requires specialized equipment and manpower. Apart from this, epoxy and resins used in composite materials add up to the cost. For instance, to manufacture carbon fiber in United States, it takes up around $15 per kilogram. In India, on IndiaMart, while traditional TMD rebars of 24 mm diameter are available at 50 to 60 rupees per kg, FRP rebars are available at 180 rupees per kg, which is 3 times the price than traditional rebars. The second disadvantage is the environmental concern. During the manufacturing process, at each and every stage, carbon fibers require intense energy. Moreover, CFRP is made of composite materials involved in carbon fiber and resins, which are bonded together very strongly. Their bond is so strong that it is very complicated to separate them. Hence, recycling and reusing this material is very complicated and difficult. This leads to the increase in waste buildup. The third disadvantage is the brittleness of the material. Steel and aluminium can deform permanently under excessive loading. This is known as warning sign before the material breaks completely. In engineering terms, it is called as plastic deformation. Carbon fiber lacks this plasticity, hence under sudden and excessive load, it can break apart suddenly. So while higher strength to weight ratio, good corrosion resistance and increased flexibility makes this material extraordinary, disadvantages hinders its ability to be used by industries worldwide. But the question here lies, can something be done to address these challenges and make carbon fiber affordable yet environmentally friendly? There are a couple of steps taken in this direction. Firstly, efforts are being made to automate the process of production. If this is done, reliance on manpower will reduce, waste buildup will also reduce, and efficiency will increase. Additionally, experiments are conducted to replace the traditional raw material, that is polyacrylonitrile, with a new raw material known as lignin, which is very much cheaper. Secondly, as it is very difficult to separate resins from carbon fiber because of their strong bond, biodegradable resins have been adopted. These resins have special structures that break down under certain chemical conditions, making the recycling process very easier. Regarding the reduction of brittleness, couple of studies have been done. For instance, this author has examined the impact of temperature that is used in processing on the brittleness of material. When higher temperatures are used in manufacturing stages, the brittleness of the material increases. Secondly, the author of this research has proposed that in order to reduce the brittleness of carbon fiber, it must be combined with a material which is very ductile in nature. Herein, he has proposed that self-reinforced polypropylene should be used, since it is very ductile in nature. So combining ductility with brittleness will reduce the overall brittleness of carbon fiber. So to conclude, higher corrosion resistance, improved flexibility and higher strength to weight ratio combined with other features such as good thermal conductivity, good fire resistance makes the material exceptional. Although carbon fiber faces challenges such as higher cost of production, environmental impacts and material brittleness, these can be overcome by automating the production process. Secondly, using biodegradable resins and using composite materials such as self-reinforced polypropylene. That's everything from my end for this video. I hope you found the video interesting. If you found any value in the video, please like, subscribe and share. I'll see you in the next video. Bye bye.